Hey guys, Thomas here. Um, Last days we had a quite interesting question in the Raspberry Pi Facebook group, and the question was, how long can the Raspberry Pi with display and Wi-Fi and so on on these cells, lithium polymer cells with round about 3000 milliampere hours or 2600, and today I will show you how long the Pi can run on the cell together with a DC-DC boost converter using my cheap Chinese oscilloscope. So let's have some fun, and I will show you how I will connect everything together. So this is our setup. I will go from the cell to the positive entry of the voltage converter. From the negative, I will go to the resistor, from the resistor back to the cell. On the other side, I will connect the USB output of 5 volts through the multimeter to measure its current to the P and back again. So you will ask yourself now, oh, why is there a resistor? Actually, this resistor is used to measure the current in this part of the circuit, because we know the law of Ohm, we know voltage divided by resistance is current. So with its 0.1 ohm, I can calculate the current flowing through it and flowing on this part of the circuit. Actually, my multimeter will be connected here with the reference ground, here with the first channel to measure the voltage over this battery, so I know how much voltage is inside, or not inside, so what's the voltage level here. And the second point will be connected here, so I can measure the voltage drop over the resistance to calculate, as I said, the current. The multimeter here is only to see the current going through the, as we know, fixed 5 volt part. So we can also calculate the power used here, and also the loss inside this DC-DC converter. So let's hook it up and try it out. Yeah, so actually I just tried to hook up everything and it was something like a fail. The Pi does not even boot, it's just blocked. As you can see here, it's not booting. And also the cheap Chinese DC-DC boost converter gives a shit on it. So it says now the input voltage is something like 3.7 volts, but you can see here you can see it. When I measure the input voltage, it's actually 4 volts, so there it's already off. And the main problem is not that it's off like 0.3 volts. It actually says that the output is 5 volt. Okay, let's measure it. So the output is, yeah, it's 5 volt. Yeah, 5.10. Actually, it's fine. It's still inside the specifications of the USB standard. But yeah, this cheap Chinese thing doesn't give enough current to boot up the Pi. Or is it just this cell that doesn't give enough current? So let's check out the spec sheet. So here you can see a spec sheet of such a cell, and you can see it's something like, let's say, 2000 milliamp hours at 0.2 discharge rate, which means it's actually 2000 multiplied by 0 times 2, which is something like 400 milliamps discharge rate for this capacity. Of course, it also says discharge current fast is 1 capacity, so 2 amps, or even 2, so 4 amps. But then the capacity is not even true. And you also have to see that if your Pi needs stable 5 volts and it takes, let's say, 1 amp, it's easy to calculate, 5 volt time 1 amp is 5 watts. But you have to add the loss of your boost converter, which can be up to, let's say, 20%. So you have 5 watt plus 20% that the battery has to provide. And when the battery goes low, the voltage goes low, it has to provide a higher current. So actually the charging value, or the capacity value written here, something like 3000, like in this case, it says, oh yeah, 3000 milliamp hours. This value is never true. You also have to see the loss of your DC boost converter. You have to take into account the discharge rate of this battery. So don't trust these values, especially if you buy Chinese cheap shit batteries or Chinese cheap shit boost converter. And the point is, these values are also wrong on most of the USB power banks. On the power banks they always write, oh yeah, it's 10,000 milliamp hours or 15,000 milliamp hours. Yeah, but what they do? They just calculate up the rating of the cells. They just calculate up, oh yeah, we have one cell inside with 10,000, or we have two cells with 5,000, and they just add it up, but they never give you the value of the loss inside the converters from the cells to the 5 volts actually. So don't trust these values. Just give it a try. Nobody can estimate how long your Pi will run on a power bank or on such a cell, because it also depends a lot of the load on the Pi. If you just leave it like this, okay, it's not even booting, it's just lighting up some LEDs here, so actually it will run, let's say, like 2 days perhaps, I don't know. But nobody can answer you the question how long it takes to boot up the Pi on this. So see you next time. Thanks, bye.